Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now let me solve this particular test. This is a collection of different questions from different past papers. Now the test is on algebra and logarithms, logs and indices, or logs and exponents. I think everyone knows that exponents is another name for indices. Now the first question is about modulus inequality. There is modulus on both sides. So now the easiest way to solve this question is that we square both sides, and then we either end up with a quadratic inequality, which is in most cases. Sometimes we could also end up with a linear inequality. Let's look at the working. So now over here, when we square both sides, we actually square both sides. This is not a square root. We also square this constant over here. We get this thing, transfer everything on one side. So 0 is greater than this thing, or this thing is lesser than 0. All these coefficients, constants, they are divisible by 5. So this boils down to this. Once you reach this stage, what needs to be done? That is middle term factorization. That is the heart and soul of pure maths. When we do the middle term factorization, we get these two things, these two factors lesser than 0. When we end up with a quadratic inequality from the knowledge of P1, we always draw a sketch. And by the way, it could be about quadratic inequality, it could about cubic inequality. A sketch is a must. Now in this sketch, all we need are the roots. So there are two roots over here. We are looking for lesser than 0. That is the region below the x-axis. That means if the values of x lie between -7 and -1, the whole thing, the product of these two will be negative. That is how this thing is answered. So question number 1 for 4 marks is done and dusted. The second question, that is about polynomials. It's a cubic polynomial. Remember, the x term is missing. X term is missing, that means the coefficient is 0. A is a constant, it's denoted by Px. It is given that 2x plus 3 is a factor of Px. So let me write over here, 2x plus 3 is a linear factor. It's a linear factor of Px. That means the first thing, find the value of A. That can be done using the concept of factor theorem. What I'll do is that 2x plus 3 equals to 0. Therefore, x is -3 over 2. So if I plug in -3 over 2 in that Px, in that function, so therefore P of -3 over 2 should be 0. Why? Because it is a factor. And I was just talking about the cubic inequality, and we have our chance over here of solving this cubic inequality. So let's get started. Over here, the first thing, Px is written. Always state, even though it may sound very obvious. P of -3 over 2 is 0. And let me write over here, 2x plus 3 equals to 0. X is -3 over 2. That goes over here. So now P of -3 over 2, you write it over here. You do the mathematical operation, whether it's multiplication, whether it's division, whether it's addition, subtraction, or it's about a power. Take care of the positive negative. Negative raised to an odd power remains negative. Negative raised to an even power becomes positive. You do the simplification. We find the value of A. That comes out to be 9. The next part, when A has this value, solve the inequality. Before that, we should factorize Px completely. Now, how do we factorize Px completely? We have this method which is known as algebraic division. The slang that we use is long division, but technically the proper name is algebraic division. What is the rule over here? We have the x cube term, we have the x square, the x is missing, write it with a 0, so that everything falls in place. And then the constant term. So now over here, 2x cube over 2x, that is x square. And then x square is multiplied with 2x plus 3. We get these terms, we change the sign and add. We get -4x square, pull this down. repeat the same process. That's the same thing as we have done it in our classes, on campus classes. Everything is explained over there. So now negative 4x square over 2x, that's negative 2x. Repeat the process, pull one more term down, and in the end you should get a 0. That means this is the expression that we are dividing by this linear factor. So the product of these two, the divisor and the quotient, that is equals to this thing. So px is a product of these two. Now, is it further factorizable? How can I check? So now the litmus test of whether it's factorizable or not is the discriminant test. This is about discriminant, b squared minus 4ac. We just evaluate it. It comes out to be negative. That means it has complex roots. We can also use the term imaginary roots. But later on, we'll be studying complex number. So the proper terminology is complex roots. There is only one real root over here. The other two roots are complex. The coefficient of x cube is positive. That means it starts from the top right and it goes till bottom left. And it is cutting the graph, the x-axis at one point. So now it's asking px is less than 0. That means the region of the graph below x-axis. So now what are we talking about? We are talking about below x-axis, the region of graph below x-axis. How can we reach that point? We reach that point if we go to the left of this root. So therefore x is lesser than negative 3 over 2. And that's the mark scheme over here. Of course, the mark scheme won't be able to explain you things in great detail as I have done. So just watch the video closely, jot down the major things, pause, take a screenshot, copy it down. All these things needs to be done. This is not a fiction novel that you can just read it out. You have to actually try it out. Now the third question, what is this about? It says expand this thing in ascending powers of x up to and including the term in x cubed, simplifying the coefficients. And then state the set of values for which the expansion is valid. Let me just focus on part B first. Whenever we have this thing, 1 plus b raised to power of n, and n could be a fraction, whether positive, negative, or n could be a negative integer. What we are facing is an infinite series. So an infinite series has a finite sum. That means expansion is valid. Infinite series having a finite sum, just like we have done in sum to infinity. Common ratio lies between negative 1 and positive 1. So what do we say? We say that b modulus should be less than 1. Over here, the first term is 1. That is perfect. And what is over here? That is this thing, which is 6x. So therefore, 6x modulus should be less than 1. So let me write over here without any thing waiting for the answer for the first part. So 6x modulus is less than 1, and then we work it out. The first one is very, very simple. Let's have a look. And let me also write the expansion. So the expansion is this thing. That is 1 plus b raised to power of n. That is n. b power 1 over 1 factorial. n minus 1, b power 2 over 2 factorial. And then the series continues. n minus 1, n minus 2, b raised to power of 3 over 3 factorial. And it goes on. So now over here, let me do a bit of highlighting. So this is 1/3. This is 1/3 and 1/3 minus 1. This is 1/3, 1/3 minus 1, 1/3 minus 2. That's one thing. The second thing, that is 6x power 1 over 1 factorial, 6x power 2 over 2 factorial, 6x power 3 over 3 factorial. So instead of writing over, I'm multiplying with 1 over 2 factorial, 1 over 3 factorial, and so on. The rest is basic arithmetic, provided you should be. It's not whether you are or not. You should be well versed in your O-level or IGCSE maths, whichever caliber that you have studied, you should be well versed in that. And then this is what you are getting. This is the answer for the second part. 6x modulus is less than 1. Take the 6 out. 6 modulus x is less than 1. X modulus is less than 1 over 6. So x modulus is less than 1 over 6. 1, 2, 3, 4 terms, all done and dusted. All good, all clear? So now that was about algebra. One more of algebra. that this is partial fractions, always double check whether it's a proper versus improper partial fraction. How do we know it's proper? The highest power of numerator should be lesser than highest power of denominator. The highest power of numerator over here is what? That's 2. The highest power of denominator, this is 1, this is 2, that is 3. That is cubic. This is quadratic. Yes, it is a proper algebraic fraction. Then decide on the case. This is denominator with quadratic factor because 2x square plus 3 is not further factorizable. If it was factorizable, we would be having many linear factors, but it's not further factorizable. So now that is how we write it. We write it like this: a constant over the first linear factor, bx plus c, a linear expression over the quadratic factor. We take LCM, this multiplies with this multiplies with this. So the numerator, this thing, is equals to this numerator. No need of writing down the denominators. After LCM, it's all good, it's all same. There is a proper strategy for this. That is, we always get rid of these two by making this bracket equals to 0. How can the bracket equals to 0? X minus 2 equals to 0, x is 2. Plug that value on both sides. We find the value of a, that is 3. Rewrite this value. And of course, this is pure maths. You have to write a lot of stuff. Now get rid of b. How can I get rid of b? By making x is equals to 0. So we find the value of c, which is 6. So now a is known, c is known, the only unknown is b. Use any value which you have not used before. So in place of 2, in place of 0, choose any value. 3, 4, 5, 6, 1, anything. I chose a simple value 1. I find the value of b, that is negative 1. So now bx plus c is basically minus x plus 6, which I have written as 6 minus 6. I hope there is no issue with that. And make sure that you write down the partial fractions at the end. Do not stop over here. Do not stop over here. Otherwise, marks will be lost unnecessarily. So the final answer, that is the partial fraction. That is how this is written. Okay, so they have written A, B and C, and of course the examiner should also write the partial fraction as the final answer. Now over here, now we are starting with logarithms. So log to the base 10, that can also be written as LG. So this is a log equation, and give your answer correct to 3 decimal places. Naturally, you have to solve for x. What else is there? Whenever we solve a log equation, log y base a, in order it to be defined, in order for it to exist, 2 things are necessary. When you are taking log of something, that should be positive. At the same time, base should be positive. Base should not equal to 1. 1 is a useless number as a base. What else? Log to the base 10. I'll write this thing as LG. That thing is there. And there were 2 ways that we discussed in class. Either we write 1 as 1 LG10, because LG10 is 1. And then make this the power. And we have log on both sides, and the other one is the conversion from logs to indices. So now this I have stated very, very clearly. Whatever you want to do, state it very clearly. So LG 2x plus 1. Taken this to the other side, and also this 2 becomes this power over here. So there is a negative, and then this power, this equals to negative 1. Now, what is the rule that we have? That is log x minus log y base a, that is log x, my bad, x over y base a. I forgot the bracket. That is one thing. Second thing, log y base a equals to x, y is a raised to power of x. That is what I've done over here. So this whole thing is like y. The base is 10. And this is negative 1. So let me just, don't write 10 over here. So therefore, this is what you are getting. Then you solve this equation, and it's not factorizable. So you have to use quadratic formula. So not everything in life will be factorizable. Quadratic formula is therefore rescue. I always have a habit of evaluating b square minus 4ac. x is equals to negative b plus minus b square minus 4ac divided by 2a. I'm getting these two answers. This is one answer. This is the other answer. That is the value of x. Now always plug in original equation. Now it says give your answers. Well, when it says the answers, I don't have to check, but this is something extra that I always do. So this is something extra. And in most cases, you should make a habit of doing it. Otherwise, you will forget. Extra for this question. Otherwise, you should do it. So now plug in the original terms. What are the original terms? That is 2x plus 1. That is x plus 1, actually without the square. X plus 1 without the square. So let me just remove this thing. Hold for a second. So let me just remove the square. That is the original equation. Now what I do is that I plug in this negative value. 2 times this negative plus 1 still positive. Perfectly good. This negative, let me write this negative over here. This negative plus 1 is still positive. So therefore accept this answer. And over here, when it's positive, which is positive 18.7, 2 times positive plus 1 is positive. Positive plus 1 is positive. So this is also accepted. So both answers are all good, all accepted. Both answers are all good, all accepted. Let's move on. Another log question. This time it's more indices based, and then we are talking about ln, and this is leaving the answer in the exact form. Find the value of x for which this thing is there. So what we do is that we break it up. 2 raised to power of n, 1 minus x. 2 raised to power of 1 minus x, that is 2 raised to power of 1. 2 raised to power of negative x, which is 2 raised to power of 1 over 2 raised to power of x. That is all over here. All the x terms on one side. All the x terms on one side. That is 7 power x, 2 power x. 7 power x, 2 power x. And then the constant on the left. So now we have this thing. 14 power x is equals to this. Now take log of both sides. So log could be natural, log could be ln. Since they have used the ln, therefore I have to use natural log. So let me just highlight it. This is ln A, ln B. We want it in this form. So I have to take natural log of both sides. So log base E, you can write it. Or you can write ln. So ln 6 is ln 14 power x. ln 6 is x ln 14. And then I can just skip this step because I was writing in the exact form anyway. So now this is the answer that is right over here. And there it is. And now this question is about linear law. This is basically coordinate geometry plus logs. It's a combo of both. So now what do we have over here? We have a line that's going like this. We have 2 points on this line and we can see those points. And then for some reason the line is not coming nice, and I think that would do the job. What else is there? We have ln y at the top. We have ln x at the bottom, and they are satisfying a particular equation. That equation is this thing where n and c are constants, and we have to find the value of n and find the value of c. Now they say nothing about n. That means n would be exact. There would be no rounding off. But c, you have to give it correct to 2 decimal places. The graph passes through these 2 points as shown in the diagram. Find the value of n and the value of c. It's about coordinate geometry. It's about gradient. It's about y is equals to mx plus c. Plug in x and y, find c. And then it's about logs. And then it's about comparing coefficients. I think I missed the c. Comparing coefficients. All good? So now this is step number 1. Let me write over here. This is step number 1. That is find the gradient. This is all about coordinate geometry. Find the gradient. That is negative 0.4, which makes sense. Y is equals to mx plus c. Plug in x and y. Anyone would do. And c comes out to be 1.334. So work in 3 decimal places at least. So step 1 is done and dusted. Now let's talk about step 2. What is step 2? Step 2 is about ln. Take natural log of both sides. Take ln of both sides. When we take ln of both sides, ln x power n y square. They are multiplying, so there is a plus sign. This n goes down, this 2 goes down. N ln x, 2 ln y is ln c. Now we want y on the left hand side. So 2 ln y, taken this to the other side over here and then divide by 2. So now this over here, that is your gradient. This over here, half ln c, that is your y-intercept. So now this is step 3, that is comparing coefficient. Your gradient is negative n over 2. Negative n over 2, let me choose the color. Hold for a second, let me get rid of this thing, get rid of this thing, get rid of this thing. So now let me choose a pinkish color over here. So negative n over 2 is m. Negative n over 2 is m. Where is m? There it is, negative 0.4. So therefore n comes out to be 0.8, and let me correct myself, since they said find the value of n. Nothing to do with accuracy, because it is already exact. So there is no rounding off. Okay, I hope that's good. And then over here, the purple thing, that is half ln c, is this c that we have found, 1.334. And ln c is 2 times this. C is e raised to power of this thing is this over here. And c comes out to be 14.41, correct to 2 decimal places, correct to 2 decimal places. Let's double check. C is 14.41, n is 0.8, there is no need of this. 4 over 5 is also good, but 0.8 is perfect. And I think that's about it. So that was your practice test for what's going to come over the test week. And it's about algebra, it's about logs, and I think I have done everything to make you prepared for the test. So make me feel proud. Take care, everyone. Stay tuned on Mathematics with Shahab Yaqub.